In this video, I want to do another percent yield example. We're given this chemical reaction, and we're asked to solve this question. There's actually two questions relating to this. But the first question says that when 10.0 kilograms of coal is burned, 4.20 kilograms of methane is produced. Calculate the percent yield of methane if the coal is pure carbon and hydrogen is in excess. So we've already been told that the hydrogen is in excess, and therefore the carbon is the limiting reagent. And if we weren't told this, we would have to determine the limiting reagent, because the limiting reagent will determine the maximum amount of product that can be produced. So in order to calculate percent yield, what we need is the actual mass of the product, which we have, 4.20 kilograms of methane, and we also need the theoretical amount, which we don't have, and that's what we have to calculate. So we have to calculate the theoretical mass of methane that could be produced from 10 kilograms of the carbon. So we do that by first taking the mass of the carbon. In this case, I've converted 10 kilograms into 10,000 grams, or 1.00 times 10 to the 4 grams of carbon. And then we multiply that by the molar mass of carbon to get an amount in moles of carbon. We then multiply that through the mole ratio between the methane and the carbon, which is 1:1. In this case, it may seem a little redundant to do that, but some people need to see it. And then finally, we multiply that by the molar mass of methane to give us the mass of methane. And you can see that this is very useful, because by using our unit analysis, we end up with the desired unit mass of methane. And if we do the calculation, we end up with 13.4 kilograms of methane produced. And the percent yield now is very easy to calculate. The percent yield will be equal to the actual mass of methane, which we were given above, 4.20 kilograms, divided by the theoretical mass of methane, which we just calculated to be 13.4 kilograms, times 100%, which gives us a percent yield of 31.3% for methane. Now, the second part of the question says that analysis shows that the coal is only 40% carbon by mass, and we have to recalculate the percent yield of the methane. So if the coal is only 40% carbon by mass, what that means is that the original mass of coal that we were given, 10.0 kilograms, is actually only 4 kilograms of carbon, because 40% of 10 kilograms is 4 kilograms. So that means that that when recalculating the percent yield of methane, we have to determine the theoretical mass of methane that could be produced when 4 kilograms of carbon react. So if we do that calculation, it's the exact same as the calculation above. The only thing that's different is the initial mass of carbon, which in this case is 4,000 grams, or 4.00 times 10 to the 3 grams of carbon. Again, we use the molar mass of carbon to get an amount in moles of carbon, times the molar ratio between carbon and methane, times the molar mass of methane, to end up with a mass of methane. And if we do that calculation, we end up with 5.35 kilograms of methane that would be produced from 4,000 or 4 kilograms of carbon. And now the percent yield will just be equal to the actual mass of methane, which is the same as above, 4.20 kilograms, divided by the new theoretical mass of methane, 5.35 kilograms. Times 100%, which gives us an answer of 78.5%. The percent yield of methane for 40% carbon by mass.